Assalamu alaikum. This is 11th chemistry, and our today's topic is this magnetic and and spin quantum numbers. This is our today's topic. But before starting these two quantum numbers, I will give you a recap of our previous this previous topic where we discussed this principal quantum number and this azimuthal quantum number. So as far as these just I will give you a recap of that. In case of a principal quantum number, I have told you that the principal quantum number, it gives us the main energy level around the nucleus in which the electron is present, and it also gives us the average distance of the electron from the nucleus plus the energy associated with that electron. Now as far as this azimuthal quantum number is concerned, and this quantum number, it gives us the number of subshells which are present in the main subshell, and this quantum number also gives us it also gives us the angular momentum of the electron in a particular subshell. Now this quantum number, azimuthal quantum number, it also gives us the shape of the electronic cloud around the nucleus of an atom. Now as far as our today's this topic is concerned, we are today going to discuss this magnetic quantum number and this spin quantum number. Now as far as this magnetic quantum number is concerned, this quantum number is designated or is denoted by m, small m. Now when a source that produces, or a source producing the spectral lines is placed under the influence of a magnetic field, these spectral lines, they split further into a number of fine lines, and it was observed by Zeeman, and Zeeman, that these spectral lines, they split into a number of finer lines, and so this effect is known as Zeeman effect. Now the splitting of these spectral lines under the influence of this electric field, this is known as Stock effect, as it was observed by Stock. Now as far as the splitting of this spectral lines is concerned, we know that electron, being a charged particle, when in motion, it gives rise to its own this magnetic field, and this magnetic field produced by the electron, it interacts with the external this magnetic field, and the splitting takes place. Now the magnetic as far now we know, because of this magnetic field of the electron, the electrons which are present in a particular subshell, they in which are present in a which are present in a particular subshell, they acquire specific orientations in space. They acquire specific orientation in space called as orbitals. This is because of the external field that they give rise to these they acquire these specific orientations, and these specific orientations, and they are specified by this quantum number, what we call as the magnetic quantum number, and the number of these orbitals in a particular subshell, it is given by 2l plus 1, where L is the azimuthal quantum number. Now substituting the value of L in this equation, we can find out the number of orbitals present in a particular subshell. Now this quantum number, it can have values from minus L to 0 and plus L. Now as far as this S subshell is concerned, where we see the value of L is 0, that means azimuthal quantum number is equal to 0, L is 0. Now if we substitute this in the above this equation, the value of M, it comes out to be 0. This shows that S subshell. That means S subshell, it consists of a single orbital that is known as S orbital. Now, in case of this P subshell, where we see the value of L is equal to 1. Now the value of M, it comes out to be 3, and that is minus 1, 0 and 1. This shows that this P subshell, it is formed of these three orbitals which have got their orientations along x, y and z axis, and that is px, py and pz. Now these three p orbitals, they are oriented in space along these three axes, x, y and z axis, at right angles to each other. Now as far as this d subshell is concerned, where we see the value of L is 2, that means azimuthal quantum number has got a value of 2. The value of M, it comes out to be 5. That means minus 2, minus 1, 0, 1 and 2. This shows that this d subshell, it is formed of or it consists of 5 orbitals. Now in case of S and this F subshell, where the value of L is 3, that is the value azimuthal quantum number is equal to 3. Now the value of M, it comes out to be, comes out to be 7. So this shows that this F subshell, it is made up of these 7 orbitals: minus 3, minus 2, minus 1, 0, 1, 2 and 3. These are the values. Now thus from this clear that from this it is clear that this magnetic quantum number, it gives us the orientation in space. That means it gives us the number of orbitals which are present in a particular subshell. Now as far as this then we have got another quantum number, that is spin quantum number. Now this spin quantum number, it was given by Goldsmith, and this quantum number, it doesn't follow the wave mechanical model of atom, which gives rise to three quantum numbers. Now we see that while revolving around the nucleus, an electron also spins around its own axis. It may spin either in a clockwise direction, or it may spin in an anti-clockwise direction. Now the clockwise spin, this clockwise spin, it is represented by an arrow pointing upwards, and similarly this anti-clockwise spin, it is represented by an arrow pointing downwards. Or we can say the clockwise spin, it is represented by plus half, and anti-clockwise spin, it is represented by negative half. Now since there can be only two spins, clockwise or anti-clockwise, so this quantum number has got two values, that is plus half and minus half. Now this spin quantum number, it also leads to spin angular momentum, which is denoted by ms. Now this spin angular momentum, it is given by the relation root of s into s plus 1 h by 2 pi, where s is the spin quantum number. If we substitute the value of this s plus half, then this value, it comes out to be root of 3 by 2 h by 2 pi. So we also get this spin angular momentum of an electron with the help of this spin quantum number. Now this spin quantum number, it's of it's of great help in explaining, or it helps us in explaining the magnetic properties of different substances. We know that in those substances in which the atoms are completely filled, or where we don't have got any half filled orbital, their net magnetic momentum is given by, that is equal to 0. So such substances, they are called as diamagnetic substances, where we have got completely filled orbitals. And these substances, they are being diamagnetic in nature, they are repelled by the magnetic field. Now as far as the substances where we have got half filled orbitals, or where the orbitals are not completely filled, such substances, they possess a net magnetic momentum, and such substances, they are called as paramagnetic substances, or they are paramagnetic in nature, and these substances, they are attracted by the magnetic field. So this is about this simple quantum number. So we see how these four quantum numbers, they serve an address in explaining the various they serve an address in explaining the position, the energy, its average distance from the nucleus, shape of the electronic cloud, orientation and spin of the electron. And this is for today. I hope you would have got it. Thank you very much.